Hey guys, welcome back. In this video, we're going to take a look at something called factoring and how we can factor using common factors, and then also factor quadratic expressions or expressions where we have an x squared for the first term. Okay, so to start off, we're going to be looking at factoring, and first we're going to look at factoring using common factors. So factoring using common factors is just a way to kind of like take out something we're multiplying from all of the terms we're looking at and put it in front. And factoring is a way to rewrite an expression as its factors. And factors are pieces that can be multiplied into that expression. One way to think about factoring is kind of like the opposite of distributing. Instead of distributing something, we're going to be taking that thing out. For example, if we had 2 times x plus 3, if we wanted to distribute this, we would distribute the 2 to the x and the 2 to the 3. So we would get 2x plus 6. Factoring is the opposite, where we're given 2x plus 6, and we want to rewrite this as something times something. So what we can do is break this up. We can factor each term as much as possible. In other words, rewrite it as the product of prime numbers. So 6, we're going to rewrite, well, 6 is 2 times 3. And then we want to look and see if we can break up 2 and break up 3 anymore. 2 and 3 are prime, which means we can't break them up anymore, so we'll stop there. Once we've written it out as prime factors or prime factorization, what this is called, we're going to see if they share any factors. So that's what the common factors part is, seeing if they have any common factors. In this case, the factor that they have in common is going to be 2. What that means is we can take the 2 and in a way put it in front, and then whatever's left over will be what we put in parentheses. So 2 times, in parentheses, we have x plus 3. So as you can see, we went through the process of going in the opposite direction. So starting with 2x plus 6, and then working our way to end up with 2x plus 3. In other words, factors of 2x plus 6. Let's take a look at another example of common factors. Let's say that we're given the expression 6x squared plus, let's do 18x. Okay, so we're going to start off by rewriting these and factoring each one as much as possible. So 6 can be written as 2 times 3 times x times x. 18 is going to be 6 times 3 times x. And then for the 6, we can split that up even more. So 2 times 3 times x times x. And then looking at the 6, we can rewrite it as 2 times 3 times 3 times x. And now we've factored it as much as possible, factored both of the terms as much as possible. Next, we want to look for common factors. So what factors appear in both of the terms or all of the terms we're looking at. In this case, we have 2 in both of them. We have a 3 in both of them. And we have an x in both of them. So we can take out the 2, the 3, and the x and put it in front. So 2 times 3 times x. And then whatever's left over is going to be what we put in parentheses. So left over, we have x plus 3. So times, in parentheses, x plus 3. And then if we wanted to, we could multiply the 2 and the 3 in front. We get 6x times x plus 3. And then we're finished. We can't factor the x plus 3 anymore because they don't share any factors. So we're done. We rewrote 6x squared plus 18x as 6x times x plus 3. In other words, we factored 6x squared plus 18x. So we're just rewriting it as a product of factors. Okay, so that's what it means to factor using common factors. We want to take each term and factor it as much as possible, identify what factors are shared between both of the terms, and then move those factors out front, and then rewrite it in parentheses with whatever's left over. Next, I want to talk about factoring quadratics. So quadratics are expressions where we have an x squared somewhere in the expression. And we're going to just talk about if we have an x squared in front. Sometimes you'll see like 2x squared or 3x squared. In this video, we're not going to worry about if we had a coefficient in front. We're just going to look at expressions where we have x squared plus something. For example, we might have x squared plus 6x plus 7. So here, x squared plus 6x plus 7, and we're going to try and rewrite that as the factor. Or sorry, as the product of two factors. So we want to rewrite this as a multiplication expression in a way. So we're trying to find, our goal is to find what can we put in these parentheses in order to end up with x squared plus 6x plus 7. What we can use to help us out here is what we know about multiplying polynomials. So when we multiply polynomials, we can use the area model. One note is we're going to end up with binomials, x plus something times x plus something in both of these. And when we multiply binomials, we use the area model to help us out. So if we have an x squared in the front, we know we'll have an x and an x for these two spots to give us an x squared. When we fill out the area model, the first term is going to go in the first box, and the last term is going to go in the bottom right box, 7. And then our goal is to fill out these two boxes so that we can find these missing parts of the factors or the binomials. So we know that when we multiply binomials, we find the area of all of these boxes and then we add up all of the boxes to get our final expression, x squared plus 6x plus 7. And in these two boxes, we're going to have an x in each of these boxes. So the x squared is the first term, the 7 is the last term, and then the 6x can be written as the sum of the two missing blanks. Something x plus something x gives us 6. So we have two blanks and we're trying to find two blanks that add up to 6x. In other words, two numbers that add to 6. We also know that these two numbers multiply to 7 because if we look at this number here and this number here, and we look at our bottom right box is the two side lengths multiplied to give us the area. In other words, the two side lengths multiplied give us 7. So blank plus blank equals 6. And we also know that, I'm going to move this up here, blank times blank gives us 7. So we're trying to fill out the two blanks and we know this information. So these two key pieces of information about the blanks. So to start off, I find it's easiest to look at factors of 7. So look at the multiplication, find two numbers that work for that, and then see if they work for the other expression that we're looking at. I think I made a mistake when writing these down. Let's do -7. How I wrote it with a +7, we actually wouldn't be able to factor that. So let's do -7. So when we multiply them, we'll end up with -7. Okay. So two numbers that multiply to -7 are -7 and 1. Let's check and see if those add to 6. -7 plus 1 gives us -6. So it does not work for our addition. Two other factors of -7 are going to be 7 times -1. And then if we were to add 7 and -1, we get 7 minus 1, which does in fact give us 6. So the two blanks that we're missing are 7 and -1. So we have 7x and then -1x. Our last step is to fill out the blanks. So looking up and down, for example, we want to figure out what do we have to multiply to end up with these values. So we can look at our first rectangle here. We have something times x gives us 7x. In this case, it's going to be 7 times x gives us 7x for that box. Next, we look at the bottom ones. Here we could use either box. Let's use the first one again. Something times x gives us negative 1x. In this case, our number here is going to be negative 1. So now that we have the two side lengths, we have the two factors, x plus 7 and x plus negative 1, or x minus 1. And then we're finished. We've rewritten our expression as a product of two factors. In this case, the factors are x plus 7 and x minus 1. So just using our area model to rewrite our quadratic, x squared plus something, as a product of two factors. Let's go over one more example. Let's say we're given the expression x squared plus, let's do 40x plus, or sorry, let's do 13x plus 40. Okay, x squared plus 13x plus 40. So we're going to start off by drawing our area model. And we put the first term in the top left box, so x squared goes up here. And the last term goes in the bottom right box, down there. The two missing boxes are going to have an x in them, and then we're trying to find the blanks for these missing boxes. And we know if we have an x squared in front, we're going to have an x in both of those side lengths. Okay. So again, we know that the two missing blanks are going to add up to 13. So blank plus blank equals 13. And we know that they multiply to give us 40. So blank times blank gives us 40. So they add to the middle coefficient and they multiply to give us the last number, or the constant. So let's start off with factors of 40. 40 is equal to, let's see, two factors are 20 and 2. 20 times 2. If we add 20 plus 2, we end up with 22, which does not work because we don't get 13. Other factors of 40 would be 10 and 4. If we add 10 and 4, we end up with 14, which again is not 13, so that does not work either. 40 is also equal to 5 times 8. If we were to add up 5 and 8, we would get 13. So that works out. So 5 and 8 are the missing blanks in this problem. So we would write 5 in one of these spots, 8 in the other spot. And then finally, we fill out the missing side lengths. So for our top right box, we know that x times something gives us 5x. So that something is going to be 5. For the bottom left box, we know that something times x gives us 8x. So that something is 8. Finally, we can write out the two side lengths. We have x plus 5 times x plus 8. And that is our factored form of x squared plus 13x plus 40. And you can always check your answer by multiplying the two. If you were to draw an area model and write x plus 5 on one side, x plus 8 on the other side, these are the different areas you would get for all of the different boxes. And if you add those all up, you do in fact get our original expression, x squared plus 13x plus 40. So when factoring quadratics, the key is to find two numbers that add to the middle coefficient and multiply to the last coefficient we wrote out here. And we can do that for any expression that starts with an x squared. So with just an x squared, we can always use this kind of like trick to help us out. If we try all of the factors of 40 and none of them add up to 13, that means that we can't factor. the expression, so we would say that it's as simplified as possible, or we say we can't factor this anymore. In this case, we were able to find two factors that add to 13, though, 5 and 8. Okay, so in this video, we talked about factoring. We talked about how to factor using common factors. So look for, between the terms we're looking at, look for factors that appear in both of them, and then we're moving those out in front, kind of like the opposite of distributing. We also talked about factoring quadratics using the area model and how we're looking for the two numbers that add to the middle coefficient and multiply to the last number.